right, so welcome to our very first video for our flipped classroom. What we're going to be continuing with today is synthetic division, which is going to build and be an easier method than the long division method that we did in class. So, synthetic division, what is it? Synthetic division is a more efficient way to divide a polynomial by a binomial of the form x minus c. So essentially, all of those divisions that we did in the previous section, 8.3, we can also do synthetic division, and you'll find it tends to be much faster and a lot easier. So, let's look at a quick example. What I have on the screen currently says divide 2x cubed minus 10x squared plus 9x plus 15 by x minus 3. So, if you look at the book, it does set it up a different way. There's multiple ways to set up synthetic division. The way I will set it up looks like a long elongated T-chart. The way the book will have it, they'll have a little corner and then a line. Either way is completely fine, okay? So what we're going to do is we're going to take the constants of each monomial in our numerator and put it at the top of our T-chart on the right. So it's going to go 2, leave some space, negative 10, 9, and 15. Make sure you carry those signs with you, so that's why 10 is negative 10, not just positive 10. Okay, and then we need to figure out what we're dividing by. We're dividing by x minus 3. So to figure out what we're dividing by, we're going to take x minus 3, set it equal to 0, and solve. So we're dividing by 3, and that's going to go in that corner of my T-chart there. Step 1, take the first constant and bring it down. Now multiply 3 times 2, that's 6, and put it up underneath the negative 10. Negative 10 plus 6 is negative 4. 3 times negative 4 is negative 12. Put that underneath the 9. 9 minus 12 is negative 3. 3 times negative 3 is negative 9. That goes underneath the 15. 15 minus 9 is 6. So the first 3 digits, so our answer is going to be 2x cubed minus 10x squared plus 9x plus 15 divided by x minus 3 is going to be equal to 2x squared minus 4x minus 3 with a remainder of 6. So then we're going to add 6 and divide it by our binomial x minus 3, just like we did in the previous lesson. Okay, so if you notice, the slight difference between the numerator and the new polynomial is that the degree went down by 1. So whatever was your highest degree, which was in this case a cube, it now goes to a square, and everything just follows. So it was 2, 1, 0. Okay? Okay, synthetic division seems simple enough, right? So let's start off by looking at number 4. 4 says 3x squared minus 2x squared plus x plus 4 divided by x plus 1. So the first step is to set up our T-chart. We're going to take the coefficients and put them at the top. So that's 3, negative 2, 1, and 4. And then the number we're going to divide by on the synthetic is going to be negative 1 because x plus 1 is equal to 0 when x is negative 1. First step, bring down 3. Negative 1 times 3 is negative 3. Negative 2 minus 3 is going to be negative 5. Negative 1 times negative 5 is 5. So 1 plus 5 is going to be 6. Negative 1 times 6 is negative 6. 4 minus 6 is negative 2. So 3x squared minus 2x squared plus x plus 4 divided by x plus 1 is equal to 3x squared minus 5x plus 6 minus 2 over x plus 1. This should be a cubed. All right, now let's look at 8. 8 says y to the 4th minus 4y squared plus y plus 4 divided by y plus 2. Okay, so in the lesson we just learned on Monday or Tuesday, whichever block you are, if you notice, we skip a degree. We go from 4th to 2nd. So we need to add in a placeholder, or 0, for y cubed. So really, we've got y to the 4th plus 0y cubed minus 4y squared plus y plus 4 divided by y plus 2. And we're going to divide that. So we've got our coefficients are 1, 0, -4, 1, and 4. And we're dividing by -2. So we're going to bring down the 1. -2 times 1 is -2. 0 minus 2 is -2. So -2 times -2 is 4. -4 plus 4 is 0. -2 times 0 is 0. 1 plus 0 is 1. -2 times 1 is -2. 4 minus 2 is 2. So our new polynomial is going to be y cubed minus 2y squared plus 0y plus 1 plus 2 over y plus 2. Or, this is a more simplified version, y cubed minus 2y squared plus 1 plus 2 over y plus 2. Okay, so let's look at 16 now. 16 says 5s to the fourth minus 3s cubed plus 10s plus 2 all over 5s minus 3. If anybody's noticing a problem, it's because the binomial in the denominator has a constant greater than 1, namely being 5. And we need to figure out how to get rid of that 5. So the way to do that is to solve by taking out a 5 from the denominator real quick. So you have 5s to the fourth minus 3s cubed plus 10s plus 2. And then we take out a 5, so we're left with s minus, now 3 doesn't have a 5 to give, yes? So we need to divide it by 5, okay? And that will give us the 3 we're looking for at the beginning. Now, what we're going to do though, we want this to look as close to the original as possible. And the root of the denominator in 16 is 3/5. Can we agree to that? So since the root is 3/5, the root did not change from this step, from the second step and the first step. They're exactly the same. So we're going to solve the equation like we have it by doing synthetic. So synthetic, my root is 3/5. And then my constants are 5, -3. I'm missing an s squared, so I'm going to add in a 0. And then 10, and then 2. Excuse me. So we bring down our 5. 3/5 times 5 is 3. -3 plus 3 is 0. 3/5 times 0 is 0. 0 plus 0 is 0. 3/5 times 0 is still 0. 10 plus 0 is 10. 3/5 times 10 is 6. And 2 plus 6 is 8. So our remainder is 8. So what we got back is 5s cubed plus 0s squared plus 0s plus 10 plus 8 over s minus 3/5. Now here's a slight problem. We didn't start with s minus 3/5, correct? So we need to bring back in that 5. And so what we're going to do is we're going to multiply this by 1/5. Exactly what we took out before because it's in denominator, so it's the same thing as 1/5. Okay? So in actuality, when we distribute that 1/5, we have s cubed plus 2 plus 8 over 5 times s minus 3/5, which is equal to s cubed plus 2 plus 8 over 5s minus 3, just like we started. Now let's look at 18. 18 says z cubed plus 3z squared minus 2z plus 3 all over z minus I. So this one's also different than the ones we've done before on the previous slide because this now has a complex root. Okay, so you got to remind yourselves, what does complex numbers look like? So think back to what we did before you guys went on break. Okay, now the ways of synthetic division is exactly the same. This was actually less complicated than the previous problem. The only difference is now we're working with imaginary numbers as well as real numbers. So we're working in complex. So our root is I, and our constants are 1, 3, -2, and 3. So first thing we're going to do is bring down that 1. I times 1 is I. 3 plus I is just 3 plus I, right? 3 plus I times I. Okay, that's going to be 3I minus 1 because it's I squared, right? So that's going to be 3I minus 3. And then 3I minus 3 times I is going to be -3 minus 3I. I just distribute that I through this time. Okay, that's because I times 3I is 3I squared, or -3. And then -3 times I is just -3. Okay, so 3 plus -3 minus 3I is just going to be -3I. Excuse me. So our quotient is going to be z squared plus parentheses 3 plus I z plus parentheses -3 plus 3I plus a -3I over z minus I. Now you're probably asking yourselves, what's so important about the parentheses here? Remember, these are complex numbers, so it's treated as a full coefficient together by itself in front of the z. So if you leave off the parentheses, that's not the same thing. So what the second line says is z squared plus 3 plus I times z minus 3 plus 3I. So it's a little different. So make sure you include those parentheses because the first one is the right answer. Second one is not. All right, and the last problem we're going to look at is 22. Now, the setup for 22 and for 20, so 21 in your book, in your homework, in 19, is a little different than everything else we've done before. It says z cubed minus 2z squared minus 3z plus 10 is equal to quantity z minus quantity 2 minus I times the quotient of z plus the remainder. So q is quotient, r is remainder. And so all it's saying is you need to divide our polynomial on the left by the binomial on the right and figure out what q is and what r is. So really what we're doing is z cubed minus 2z squared minus 3z plus 10 divided by z minus 2 minus I. Okay, that's what 22 is asking us to do. So we're going to set up our synthetic division. 1, -2, -3, and 10. And our root that we're dividing by here is 2 minus I. Okay, so it's a little bit of a harder complex number this time. We're going to bring down the 1. 2 minus I times 1 is just 2 minus I. -2 plus 2 minus I is going to be -I. I times 2 minus I is going to be -2I plus I squared, or -1 minus 2I. -3 minus 1 minus 2I is going to be -4 minus 2I. And 2 minus I times the quantity -4 minus 2I. You've got to FOIL on this. So when we FOIL on this, we get -8 plus 4I minus 4I plus 2I, or -8, the 4 i's cancel, minus 2, or -10. I'm going to draw a little line there. Okay, so 10 minus 10 is 0. So Q of Z is going to be Z squared minus I times Z plus -4 minus 2I, the complex number. And the remainder is going to be 0. And that's my answer. So that's the lesson. That's your homework. After you fill out the form and turn it in, you're done for the night. Okay. If you'd like to get started on the classwork ahead of schedule, that's totally fine as well. Just remember that it's due by the end of class, okay, on Wednesday. So you have 45 minutes to do it. And it's page 370, numbers 1 through 21 odd.